The Secrets of Technology is brought to you by the StarQuest Production Network and is made possible by our many generous patrons. If you'd like to support the podcast, please visit sqpn.com/give. Hi, I'm Dom Bettinelli, and you're listening to The Secrets of Technology, where we discuss the technology news that's important to you from a uniquely Catholic point of view. Joining me today on the panel are Thomas Sanjurjo. Hey, Thomas.
Hey, Dom.
And Jack Baruzzini. Hey, Jack.
Hey, Dom.
So today we wanted to talk about something about... Sometimes we talk about stuff that's very down-to-earth and like very practical applications, and sometimes we want to talk a little more conceptual, and that's what I wanted to talk about this time with you guys. Thomas, you suggested that we talk some biotech topics, and so we're going to dive into the topic of CRISPR and gene editing. And CRISPR is a gene editing technique that's been around for a little while, a few years, and it's kind of revolutionary because what it allows is it gives scientists and doctors the ability to modify DNA with precision. That's the key. They're able to get in and change very small portions of the DNA molecule. You remember that from high school biology or chemistry. The DNA molecule, the double helix, and to get in there and change it for very specific purposes. And that precision is important because it means that they can make predictable changes, not just random mutations and hope for the best, that sort of thing. So it since it's come out, it's revolutionized genetics, giving potential treatments for genetic disorders, advancements in agriculture. It allows us to look into the fundamental biological processes in the world. So it's been a really big deal. Just in in 2023, the FDA approved the first CRISPR-based therapy to treat sickle cell diseases and beta thalassemia. It lets them edit patients' blood-forming stem cells to produce healthy hemoglobin. They found that in fetal stem cells held more hemoglobin than in adults who had more fetal blood cells or stem cells. Sorry, they held more hemoglobin than adults who didn't, and the ones who held more hemoglobin were better off. I'm sure the scientists would look at that and go, "You had that all wrong." But you get the idea along those lines. It treated these very well. So it's kind of exciting. Do you guys have much understanding or looked into much about CRISPR?
I have a friend that is really into it. That's actually like a CRISPR scientist that does some of the work on it, and it's really interesting listening to them talk. But it is kind of like they're from another planet,
right?
And I think we all kind of feel like that to some degree or another when it comes to like the really advanced biology concepts. But the way that they explained it to me was that all of your cells are made up of smaller microorganisms that at some point in evolution kind of combined together to become part of whatever cell you have. And you think about like the human microbiome, we're made up of most of us is actually other stuff. And so kind of what they're doing with these things is being able to decant what makes up our biology and then actually build pieces to it that they can fix things, they can change things, and they can make, fix some of the effects that process has on us to the point where we can actually become more healthy by using some of these gene editing tools.
Right. Because as you make the point, like we are what, we've all the answer how we eat, but we are literally all the things we've consumed, whether it's food or air or the world's around us, or what we've received from our parents, or we share genetic commonalities with animals and other and the rest of creation. Frankly, at some fundamental level. So we are this amalgamation of so much of the world around us, and so being able to kind of get in there at that very low level and using something like an analogous to molecular scissors to cut through. Because the first big breakthrough was the Human Genome Project 25 years ago, where they first mapped the genetic structure just to give a broad map. Now we're at the point of, like, it was like the first time they sailed around the Earth and had a map of the continents. Now we're at the level of satellite imagery, where we can see everything, down to a low level, by analogy. So it's really kind of amazing. And it comes basically in two forms. And when you think about it, it makes sense. They divided somatic gene editing and germline gene editing, which basically means the somatic gene editing is the stuff that when they do it, it affects just, like, if they do it to you, it affects just you. Whereas germline gene editing, it's changes that can be passed down to your offspring. And that's an extremely important distinction when we talk about the safety of this and when we talk about the morality and ethics of it. So, right off the bat, that's two big distinctions. And then there's the stuff we do to humans and the stuff we do to other biological non-humans, and then the stuff we do to inanimate objects, like plants and that sort of stuff. So there's levels of this, of distinction when we talk about the different kinds of gene editing that CRISPR does. And
the comparison too is really like, we've been doing this historically for a very long time. It's just that we've never had the tools to do it directly to the genes. We've done it to a whole species before, So it's like, we'll take dogs and we like that this one's short and can fit into holes to hunt rabbits. So we breed more of them just like that. And then we'll do the same thing with another. Well, now you can learn what those particular genes are, what expression of genes makes that trait. And you can kind of fix for it in animals. So if you need a healthier, long-lived animal, more disease-resistant animal, you can kind of build that kind of stuff. It's not perfect science still, but it's better than having to wait, 5-6 generations of breeding them to get to that point when we need to make those kind of changes for sustainability.
And that's kind of like you'll see online people get very upset about things being non-GMO and they don't want any GMOs in their food. Well, any modern food is genetically modified already. We're not eating the original wild strains.
Yeah, the corn we eat today bears no resemblance to the wild grass that was first cultivated 4,000 years ago by Mesoamericans. It was barely edible then, even. And by being more precise and more accurate, it's better for the species that we're manipulating or modifying. In that, sometimes when we would breed for particular characteristics, there were the unintended consequences that came along with it, and so they became more aggressive or dumber or various bad outcomes,
breathing problems,
like dogs.
Yep. Well, the same was true of crops too. Like, we had a lot of trouble with crops where you would breed crops for particular environments, and then they would be more prone to disease because they were much more genetically single strain. Whereas you can keep some of that genetic openness and just change that particular expression that you're trying to change in any given species.
When you're breeding for a trait, you're often bringing a whole bunch of other traits along with it. Whereas with gene editing, you can bring one trait. That's the goal anyway. I mean, that's what they're working toward, and probably in some cases have reached that with some of the applications. So yeah, I mean, that's an important point too that you made, Jack, is that we eat GMO. Everything we eat is GMO. It's been modified. It's how it's been modified. I remember, again, back to high school, learning about the friar Gregor Mendel with the peas, learning how to I forget how
Mendel squares.
Yeah.
Yep.
It's been 45 years, so it's been a while since I've done those. But yeah, but learning, like this guy, man, the monks in his monastery must have ate a lot of peas. Say it. Just occurred to me. But that itself was a form of genetic modification. And I get what people are concerned about is because we've seen the science fiction stories, what if they do something horrific that gets out into the wild and causes mass die-offs or creates a poison or a mutation that's terrible for everybody. And those are that's a valid concern. And you have to, just like with a lot of advancing technologies now, we have to have guardrails, we have to have oversight, we have to have accountability and transparency. But it doesn't mean that we can't do this because the promise of the benefits are so high. Mm-hmm. So some of the breakthroughs that they had, like I mentioned, the sickle cell disease, they're also exploring CRISPR to treat cystic fibrosis, muscular dystrophy, certain cancer treatments where they can target just the cancerous cells, the tumors, without damaging the healthy cells, which is the problem with chemotherapy and radiation treatment now. And these are all diseases that are untreatable today, like cystic fibrosis and muscular dystrophy. Those are, incurable. There are treatments and therapies, but it's more just treating the symptoms. It doesn't cure the diseases. And so it's amazing the promise. Now, we've had lots of promises over the years for miraculous breakthroughs in medicine. So the proof will be in the pudding once they have it. But it seems like CRISPR is a promising path potentially to that. It looks awesome.
Yeah, well, and there's a lot of interesting applications, even just in the science of studying diseases, because of what we've learned by being able to manipulate these, foundational pieces of what makes up the genetic structure. We can actually now go and review those things that we've been looking at previously in a whole new light. And I think one of the coolest that there's a whole AI model that went through mapping proteins, and they've used Google's mainframe for mapping. And essentially, like there's always been this really big problem that proteins can curl up in these odd ways, and so they couldn't ever figure out how to map them properly. And it took them hours and hours and hours to try and validate what they'd done. Well, this thing can go through and do it super fast, and we've made a leap from a fractionally tiny amount of proteins that we have that we know of in genetic structures just a couple of years ago to almost all of them at this point. And the outliers are really just interesting outliers, and that in and of itself is very interesting. But like the study of this stuff is advancing so much because we're able to get in there and learn all of the building blocks. It's almost like having Legos to build all of the genetic structures that we've just been able to guess at before.
That is wild. There was a video on the Smarter Everyday channel maybe a year ago, I forget how long, where he was actually in a lab where they were talking about gene mapping, or not gene mapping, like molecular level mapping, like in analysis. And he was talking to the scientists, and as he does so very well, explaining how can we see something so small that you can't see with a visible eye, like with a visible light, like you can't see it. How do they do that? And it's pretty amazing how they, are able to see these things. And that's part of what this is being able to, manipulate these things means being able to see these things and getting down to that level. It's pretty wild. And we mentioned agriculture, enhancing crops and making the livestock more disease resistant. Disease in livestock is a huge problem. This is one of the reasons, a lot of the beef that we get is pumped full of antibiotics and hormones, is because the way that they're raised on feedlots, they're all in tight conditions. They pass diseases to one another, and so they pump them full of antibiotics. But that's not good in the long run because it means they end up becoming, antibiotic resistant strains of diseases, and it's not good for the cows and ultimately for us. So if you can make them disease resistant in the first place, you don't need to pump them full of steroids and antibiotics and all that sort of stuff. There was another interesting story. There'll be a link in the show notes about like they edited a tomato to make it 20 or 30% increase in glucose and fructose. That's the sugars, sweeter tomatoes. So, even at that level of making more appealing fruits and vegetables for us, sweeter tomatoes, CRISPR, different kind of CRISPR apples, that sort of thing. That would be an interesting marketing for that. These are the CRISPR apples because they're crisp. I don't know. But you know what I mean? Like, so just that idea of being able to bring things to market that are more, what we want, without having to go through the hoops. To bring a new apple to market, for instance, like Honeycrisp, I think I remember seeing somewhere it took like 30 years to bring it to market from and the way they do it is they just keep growing, grafting and different varieties of trees, different trees together, and then testing the resulting apples. And then when they get an apple that's really good, then they clone that tree. Like every Honeycrisp you eat is from a clone of the original Honeycrisp tree. That's how apple varieties work. And which is kind of crazy, because if anything ever happened to that one clone, that one, if there was some disease that attacked just that one. Yeah.
Yeah, and that's the big problem, is that the way we breed things currently, we breed them to be very homogeneous, and so we have the situations like that where there's just a clone of a single strain of the good stuff, and we keep using it over and over and over again, and just hoping that it doesn't go bad, or a virus doesn't develop that takes it out, or a mold or something like that. The alternative here is that, well, if that one goes bad, we can have 20 others in pocket ready to go that do roughly the same thing, but maybe now we can add a resistance to that particular virus and then just put that out there. So it's really like it's an interesting place to be, and I think there's real concern. Like I don't want to like totally like put everybody who's kind of in that bucket of being worried about it in the like crazy bin, right? Because they're not. There's real concerns about what could be happening. But one of the things that I think is really important to realize too is that none of this stuff is passing to us with these changes that we're making. In most cases, there's some situations where, like with beef, where there's the hormones that are still close enough to what we have inside of us that can be an issue. But for the most part, where we're able to really make these differences for animals and for the plants that we're eating, it's really beneficial across the breadth of agriculture, rather than just like the focus of like the one or two little things that might be dangerous.
Right. I saw one story talking about how scientists are exploring the use of CRISPR to modify mosquitoes, turning females into non-biting males, trans mosquitoes, to reduce the spread of malaria. So the only way we've been able to do this now is spray pesticides everywhere to try to kill them off. That's the thing. And there was another one where they were trying to, they were catching the mosquitoes and sterilizing them with a spray chemical. But this is like, really neutralizing the whole breed of them to prevent malaria, which would be really great. So there was another story about designing microorganisms that are capable of breaking down biofuels. So creating biofuels, making fuel that's a replacement for oil, or breaking down pollutants. So when there's sewage or oil spills or chemical spills, cleaning it up naturally using these organisms that eat that sort of thing. So it is fascinating to think about all the different ways that we could, if we had access to this technology, where we could, edit, genes in an organism, micro or macro, what we could do with it. And there's just so many different ideas.
Yeah, there's one about making a bacteria that can eat the microplastics, which is just
yes,
that's so cool. That's like that's a really a human-made problem with a human-made solution. I like those.
Right. So, from a ethical and moral standpoint, there is some, the church has, we're a Catholic podcast, so we're going to talk about what the church has said. So the church does say gene therapies that are strictly therapeutic to treat or prevent disease, those are fine. Those are, in the broad categorization. moral. We'd have to look at individual ones to make sure that everything is. It's when we start getting to genetic modifications for enhancement purposes, or for selecting desired traits in our children. That's when we start to get some ethical dilemmas. If we're using gene editing to change our children, or to edit out undesirable traits in our society, that's where it leads to some really strong moral problems, because we're not to manipulate people. People are not objects to be manipulated. It's a fine line. I guess it's a tricky distinction to make between treating a disease and changing a person for purely enhancement purposes. What do you guys think of that?
I think that's really when I'm going to be one of those things. It's a very, very case by case basis, because where's the line between a treatment and an enhancement? Because for many things, like with the germline CRISPR, or when you're like editing genes in a person that will be passed down to their offspring, that can be therapeutic, but also as an enhancement.
Right.
So there's a lot of fuzzy gray area there.
Right. What if, so we remove the genetic predisposition to asthma, say, that a family might have. And that way my children and their children will no longer have the threat of asthma or heart disease or breast cancer or whatever. But what if I want my child to have brown hair instead of blonde hair?
Yeah. That's designer children.
Yeah. And here's a tricky one, and this is a controversial one. What if I want to ensure that my child who has been diagnosed with Downs in utero doesn't have Downs? We edit out that, we fix those genes, or blindness or deafness or other things that we call handicaps. That's a gray area to me. I don't know where we would stand on that.
And it's interesting too, because then you can look forward and see things like, well, if there is an area where we're trying to live that is covered in smog and awful for breathing, but we can edit it so that people could breathe, dirtier air. Is that therapeutic, or is that,
Right. Exploitative, yeah.
Right.
So that,
instead of fixing the smog.
And I think that's really where we need to take a look at these things and say, okay, well, what is it that we're trying to fix? In some cases, I think that, there's nothing necessarily wrong with people that needs to be fixed, rather than just we need society to attempt to make things accessible to people. Right. Right. And then the other side of that too is, how much does this all cost? Because if it's something that, well, I can fix my kid's blindness, but it's going to cost this much money and it's not accessible to most people in the world, that's problematic in a different kind of way, right? It's therapeutic, sure, but it's, we're not fixing the problem for everyone equally, and then potentially causing more divide in what is a human, and what is, a human that has the ability to be perfect versus a human that doesn't.
Yeah. Gattaca, altered carbon, there's been a whole host of science fiction stories that have covered this idea of the elites being given the ability to genetically enhance themselves, make themselves more perfect, while the rest of us, are denied access to those because of cost, or just because it's reserved for the elites.
Yeah.
So, it's there's a lot to think about here. It bears watching, and like we said, there isn't any one way to think about it. There's a lot that's going on. So we have to, one of the clear areas is editing embryos, unborn children. It has to be very, like, editing to enhance or for eugenic purposes. There's a loaded word there. Bad, but to fix abnormalities, genetic disorders, various in utero problems that could cause stillbirth or other problems after they're born, that would be different. In fact, we already allow operations on fetal operations, operations on unborn babies, in order to help them survive after they're born or survive to birth. So so it bears watching. So we also have to be aware of the potential risks. Like we said, unintended genetic modifications could lead to unforeseen health issues. So we have to make sure that the gene editing itself doesn't make things worse. And that's what the whole testing, process is all about that they go through. And of course the equity and access, factors. In the future, they're talking about all kinds of amazing, precise gene editing tools that they're developing. There's one called prime editing, which allows for the correction of specific genetic mutations without cutting the DNA double helix. So they could fix things without even cutting the DNA, like pulling it apart. I don't even begin to understand how that works. So that's fine. I trust that they're the smart guys. So it is a fascinating thing. I think more people should be aware of it, and that's one of the reasons why we're talking about it, because this is one of the most promising areas of scientific research that could bring about some of the biggest benefits to us, more than AI, more than the new smartphone, more than any of that stuff. This sort of thing has the greatest potential for our children and grandchildren living better lives. Better lives.
And it's such a sleeper topic too. Like AI gets all of this coverage in the media. And I mean, the dangers for both are very, very real. Like there's very real dangers for AI. There's very real dangers for biotech. But it's interesting to me that AI gets so much more media attention. I think it's just kind of, more accessible in a weird sort of way to the average person.
I think because with AI, even though it can be very hard to understand how AI actually works, people understand the concept of, it's a computer that can talk to me much more than we're going to edit these individual gene strands and like all the stuff that goes into that. Mm-hmm. You can also access AI just as a normal person now, which you can't with CRISPR.
That's very true.
And we've all that bad sci-fi, like in Star Trek, where their genes have been changed, and now he's a salamander. It's hard to grasp. I think even for the sci-fi writers to grasp what these things are about. One recommendation I've seen, I haven't read it myself, but I've seen recommended if you want to know more about this fascinating area from a popular perspective. Walter Isaacson, the famous biographer, actually wrote a book called The Code Breaker, which goes into the development of CRISPR and its implications. So if you folks are interested in learning more, check out that book. I haven't read it myself, so I'm not recommending necessarily, but just throwing it out there is something I ran across in my research for this episode. So excellent. So we'll continue to talk about biotech topics in the future. I think it's a fascinating area, and there's a lot of technology in there that's worth talking about. And maybe when we talk about biotech and agriculture, we'll bring our friend farmer Matthew back to talk about maybe some of the stuff that he's seeing in his field, literal field.
That'd be great.
So that'd be great. All right. Before we move on, I do want to take a moment to thank our patrons who make it possible for us to create Secrets of Technology, including Travis F., Foster A., Richard C., Andrew C., and Santa S. Their generous donations at sqpn.com/give make it possible for us to continue the Secrets of Technology and all the shows at StarQuest. And you can join them by visiting sqpn.com/give. So our first headline today brings up an interesting topic. It says from the Wall Street Journal, and wait for this page to reload in my browser, and it says when a lifetime subscription can save you money and when it's risky. And it's an interesting look at this topic of subscriptions. We're seeing subscriptions everywhere. We've talked about it a number of times. Your car wants you to subscribe. That's our thing now that Mercedes has a subscription. If you pay $60 a month, your Mercedes EV will accelerate faster. Like, that just seems bizarre to me. And so we're all getting this subscription fatigue, which is just, bombarded by this. And so some subscription people who are offering subscriptions are saying, hey, look, you can opt out by getting a lifetime subscription. You pay one fee and now you never have to pay again. But of course, that's a little risky because does the one-time fee, is it worth it? So what do you guys think? We can get into some of the details of what the article talks about as we talk about it. But what do you guys think of? Do you look for lifetime subscriptions for stuff that you use?
I've looked at some of them. There was one, I think it's Box. It's a online backup company. They do lifetime subscriptions. It's like $500. So it's a lot of money, but it's not like you're paying $10,000 for the rest of your life, unlimited backup. And every time I've looked at one of these lifetime subscriptions, I've kind of viewed it as, okay, this is a 5 to 10 year subscription at most, because I don't trust that A, the company's not going to go out of business, or B, they're going to change up their business model at some point, and your lifetime subscription is going to be gradually downgraded, or they're going to start moving features from that subscription into a tier where they can actually continue to collect revenue. Because from a business standpoint, a one-time fee for a lifetime subscription just doesn't really make a lot of sense.
Right. That's one of the things the article brings up is it good for the company that's offering the subscription? Because then, what might happen is they'll need to find new ways to continue to make money. Mm-hmm. And some of those ways include selling your information of various sorts. Yep. Which is bad. I'm glad I never bought like a lifetime subscription to, say, Evernote. 15 years ago, Evernote, I thought was going to be around forever. Yeah, it was the best thing. And I would have gladly, paid a big chunk of money to make sure Evernote was there for me. And then, a few years ago, they sold to this new company, and it's a completely different product. And I abandoned it and I would have been mad if I, spent a bunch of money and,
for a lifetime that you no longer are going to use.
Yeah, exactly. Mm-hmm. Exactly.
That's the only one I've bought lifetime subscription was Plex for the media.
Same here.
And my reasoning there was, Jack, like you said, this is a 5-year plan for most companies, but with them, it's really interesting because they're a media company on top of having all of the services that they provide. So the lifetime subscription is really for the services they provide. And then they do have, like movies that you can watch, and they have ads running in the movies and things like that. So they have a really interesting model. And that was one that I was completely comfortable paying the lifetime membership for. But for the most part, yeah, I agree that you really need to think of a lifetime subscription as like a 5 to 10 year. Right. If I paid for this for 5 to 10 years, if I paid this amount, would that be an appropriate amount for me to pay? Yeah, exactly. And that's really the question that it comes down to.
There's a bunch of like apps and things like that on my phone or my computer. They're, it's $4 a month or $50 a year, or if you pay $80, you get it for free. I'm like, am I going to like that's like 2 years worth. Like if I just kept it for 2 years, I'm ahead of the game. Mm-hmm. Sure, I'll do that. That's fine by me. But there was one they mentioned, like there's a waking up, a meditation app where the lifetime subscription is $1,500, and they say you'd need to use the app for more than 11 years to just break even. And it's like, do you know, like, how many of the apps that you use today were around that aren't major corporations are still around after 11 years? I mean, it may be, but that's rolling the dice. I can imagine that. And it's an opportunity cost issue because you're laying out all that money up ahead in advance. Whereas if you pay out over time, you get the use of that money, that $1,500 over time, as opposed to giving it up. So,
and it keeps them hungry. They have to, they have to keep working, That's,
right. And there's
I
also
feel like there's some level of that,
Yeah.
We're also seeing with, I know that Humane, that company that made that AI pen.
Yes.
That came out. They just announced that they're going to be all the services for that pen are going to turn off in like 10 days. And everyone who's put all this money towards this device, it's now a paperweight.
Right.
And I think that's another thing that happens with a lot of these companies is there's nothing you can really do if the company goes bankrupt or gets bought out, and they're just like, well, we can't support you anymore. Too bad.
Yeah.
Right. And that's happened too often with a lot of these smaller startups to really ignore that. Like if Apple offered me a lifetime subscription to iCloud for a reasonable price, I might go for it, because do I have confidence that Apple's going to be around for the rest of my lifetime? Probably. Same with Google, same with Microsoft. I mean, they're big enough they're probably not going anywhere. I mean, it's not certain. But companies fail.
They also know how to run their business. Right?
That's why they don't offer lifetime subscriptions.
Yeah. Exactly. In fact, I think I saw Apple was their Apple Care. They're pushing the month to month over the annual plans because better in the long run. But the article has this guy who's a marketing professor who offers basically, this is the best way to look at it is divide the lifetime fee by the annual fee. And that's the expected lifetime in the sense of, like we were just talking about before. So if it's $500 lifetime and $10, so that's the number of years that it will take to break even. If you're sure you use the service longer than that, you'll come out ahead. Now, he says, but be realistic about your usage. Consumers are very, very bad at predicting their future tastes, which is why beauty and fashion related products are he says, don't do it for this, because beauty and fashion changes.
Yeah.
It changes with the season. So stay away from it for that sort of thing. So if you're a new user, try a cheaper short-term plan. Am I going to want to stick with this long-term? That's where we get the mention of the Mercedes-Benz $60 a month subscription to boost the acceleration on your EV, or you could pay $1,950 for the lifetime of the vehicle activation. Now, how long are you going to own that vehicle? That's right. That's 16 to 19, like 6 to 995.
That's actually not bad. If you think about, like, because then there's always the insurance of
32 and a half months. Yeah. It's basically 32 and a half months.
Yeah. So you're going to have it for
I can see owning a car, a Mercedes-Benz EV for at least that long, I guess.
Yeah.
But, and Mercedes-Benz isn't going anywhere. That's the sort of thing. So,
And it's also good to think about when they say lifetime license, they mean a lifetime of this particular product, not your lifetime. And I think a lot of people think my lifetime when they see that term. It's like, no, it's the lifetime of whatever particular product you're getting.
Right. Exactly.
So when we make version 2, this is not transferring over.
Yeah.
Probably not. Right. They'll give you a discount on the next lifetime subscription.
Yep.
They'll do that for you.
I've had that happen with several different apps where I've bought like the premium version for like $25 and then they release the new version and it's a different version, so you don't get it.
Yep.
Yeah.
Gone are the days, however, when you can buy a product and own the product.
Yeah.
Yes. So then I wanted to move to our next headline, which is from the MIT Technology Review. It says that Nokia, there's a name I haven't heard in a while, is putting the first cellular network on the moon. So this isn't just a stunt, because when you think about it, right now when we go to the moon, we go into space, there's not a lot of traffic competition for the airwaves out there. But as we go back to the moon, and we start commercializing it and putting permanent habitations there, there's going to be a lot more people trying to communicate. And so we need better communications networks. And so they're deploying on a new lander that's going to the lunar South Pole. It's going to have a fully functional 4G cellular network box on the lander to communicate between the spacecraft, the lander, and a rover, and there's like a hopper that like a little helicopter or whatever that they're gonna, probably not helicopter because the atmosphere, but something that can fly around on the surface of the moon to help communicate. And this is just proof of concept, because we need to get to an actual communications network. And not too long from now, it's these sorts of stories that make me like really get excited because it means it's happening. Like this isn't just, hey, someday we're going to go back, but like we're really putting in place all of the infrastructure, all the building blocks for what it would take to have a permanent moon base. Like, guys, we're going to have a permanent moon base in our lifetime, maybe. God willing, I'm alive. I just love that idea.
I want to visit it. That's my get it done so I can go there.
Does my cell phone roaming plan include this? Is what I want to know.
Well, the funny thing is, they say in the article that if you happen to bring your smartphone to the moon and it somehow survived both the trip and the brutal lunar conditions, it should work on the moon just like it does on Earth. It is a 4G LTE cellular network. You just need the lunar SIM card to go with it, which probably costs. The data is probably killer, but
I bet you one of those old Nokia 3310s could survive on the surface of the moon, no problem.
Oh, 100%. That's going to be there long after the meteors.
Yeah,
that's probably why they're sending Nokia to do this. Yeah, Nokia is owned by somebody. They had a different name for it now.
HMD, I think. Is that them?
Nokia Bell Labs Solutions Research. So I don't know if they bought Bell Labs or Bell Labs bought them or something, but there's a combination. Bell Labs is famous research, came out of the phone company years ago, but went independent and has been famous for its technology and research over the years. So our last one is a bit of a cautionary tale. Folks will probably have heard of Zelle as a payment service that the banks promote. And if you want to send money through someone, you don't use Venmo or the Cash App or Apple Pay or Google Pay. You can use Zelle, which is, again, something that through your bank. But starting with Chase Bank, and probably other banks will follow suit soon, they're going to start blocking Zelle payments to social media contacts, because they found that there's a significant amount of fraud coming from people sending payments through Zelle to people they meet online. So whether it's Nigerian princes or people, selling scammy stuff on Instagram ads, that sort of stuff. People are using Zelle for that. And the banks are saying, no, Zelle is always intended to send money between you and someone a family or a friend in person, that sort of thing. And they're going to start actually making you verify how people for certain transactions coming up. So I don't know. What do you guys think? Should they just let people do what they want? I mean, is this too much Big Brother, or do we really need these guardrails?
I've honestly found Zelle to be very unintuitive, and I gave up on using it because it's not that good of a transaction system to begin with. It's easier just to use PayPal or Venmo, so I really don't have an issue with it, and I can kind of see the demographic that would probably use Zelle might not be tech savvy to begin with, and so it makes sense to have some more precautions in place. Because if you want to send money to someone, it's not hard to do. You don't have to use Zelle.
Yeah, when my father-in-law sends money to us, for Christmas or birthdays or whatever, it's always through Zelle. Yeah. But when
we've lost a big payment from my dad that way, because he went to send it, and it was like, I don't know what he put in wrong, but it went to somebody and it never came back. And there's no way to dispute it. It's just, there it is.
That's the big thing. There's no protections in Zelle. There's not like with a debit card or credit card or anything. Like even the little protections you get with debit cards. There's no protections for it. So you're kind of on your own there. For us, like all of our transactions, like, so we are a scouting family. We have two different troops that we're members of, and all of our transactions with the scout troops now are all through Venmo. We just, the treasurer usually sets up an account, and money comes in, and they send it to the troops bank account that way. And that's how we pay for our kids' karate lessons. And, that's just how everybody does business now, is through things like Venmo. So, Venmo isn't without its dangers too. There aren't the protections there really either.
So that's why, I'm a fan of PayPal. If where possible, I try and encourage people to use PayPal, because there's a little more of a gap there, and there's a little bit more backing from the company. Where if you say, "Hey, I just disagree with this transaction," they'll do at least they will put in nominal effort to try and get it back. So.
Yeah, PayPal has its issues with sometimes holding people's accounts. Like they're overzealous in protecting others. Like I've heard of people who have accounts where they, like their Etsy store or whatever, and they lost. PayPal just kept all their money because they're like, no, you were being fraudulent. Like, no, I wasn't. And so again, it's tricky. But I do love the fact that we do have a way for doing micropayments now for small. I mean, I wish we had even more micropayments where we could do like, nickels and dimes and quarters to subscribe to things like Substack, accounts and that sort of stuff. But if you need to send, $2, $3, $4, $5 to somebody, we can do that now. And I like that it's much easier to do that. All right. So those are our headlines this week. Let's move on to our picks of the week. Jack, why don't you go first? What's your pick this week?
My pick of the week is a MagSafe car mount from a company called Lisan. It's something I found on Amazon. I got a couple of them, put one in my wife's car, put one in my car. And it's like $12. It's normally, I think, like $17 or $18, but I found it for $12 online, and it's got an adjustable arm. You can angle the phone however you want for using your GPS and stuff. And I don't even have an iPhone. I use a Android phone, but I have like one of the MagSafe cases, and it works totally fine with that. And it's much safer, a safer way to navigate than putting your phone in the cup holder and constantly looking down. So definitely recommend it.
That's cool. And it's a charger too, or is it just holder?
It's just a holder.
Okay. Yeah. Yeah, I mean, that's actually not a bad idea. I feel like if you just want to be able to, put it someplace safe while you're driving, and you need to charge it. It's an inexpensive way of doing that. Yeah, I like that. Good pick. Excellent. Thomas, what's your pick this week?
So I went with a cardiogram app. This one's really interesting. I like this app a lot. I had to go in for some heart monitoring work, and the doctor asked me to get a cardiogram app, but he didn't really say which one. He just said to find one. And my Samsung Health that works on my watch was okay, but it wasn't really giving me like super updated clicks. So I went and found this one. It's hilarious looking at the reviews. So if you go to the reviews on the Google Play Store, it's got like 2.5 stars because it's a pay app. It is not a free app. They give you like a 30-day free trial, but it's not even really a free trial. So it does cost you a little bit of money. It's like $15 a month for a family plan. So you can have multiple people on it. It's not super expensive for what it is. So if it's something that, if there are heart problems in your family, it's a good app. You go to the Apple Store, 4.5 stars, like 4.6 stars, because Apple users are comfortable paying for things. Right. So if you are looking for a really good heart monitor, it's very up to date. It keeps time with you in real time. So if you have a wearable device that you can sit and do a very, very measured tracking of your heart rate, or it just kind of gives you a periodic look throughout the day. That's a lot more detailed than some of the other like Fitbit apps and things like that, because its real focus is on these minute details. And it can even catch things like murmurs, heart murmurs, and little inflections in your heart that aren't necessarily going to be caught by the other apps, because they're just trying to do their best guess to get your heart rate in general. This one's really detailed and really looks a little bit more deeply at what's going on with you.
I actually have this app on my phone, and the free version, it gives you the basic timeline, especially if you've got an Apple Watch and you're an Apple user or even an Android watch. You're going to get a lot more data that way, so if you have it. But and there's already a lot of data that you get in the health app. But this gives you like a timeline. It lets you log like I have AFib symptoms. Click a button and enter in how am I feeling today and that sort of stuff. And then if you get the paid version, you get a whole lot more metrics, and so as you mentioned, the reports and that sort of stuff. So you could download it and try it out. The the free version for a bit and see, But I can understand why your doctor would tell you, because you can get buried under the data a little bit if you just but if your doctor wants you to send him or her your information, that's detailed. This sort of app gets a lot of detail that would be useful to them. So that's really cool. So what's my pick of the week? Mine is, that's right. It is yet another Anker laptop power bank. This is the Anker laptop power bank, and this was introduced at CES this year. And I must just admit, I'm a sucker for Anker batteries. I just all the different form factors. But what sold me on this one is it's got two built-in USB-C cables. One retracts, is a retractable cable in the top, and one is the lanyard. So it's this clever thing where if it's the lanyard, it looks like a lanyard, then you kind of take it apart and there's a USB-C plug on the end of that. Nice. And you plug it into stuff. It is a really powerful. It's a 25,000 milliamp hour charger. It's a 100-watt charger, so you could charge a laptop with it, no problem. And you could charge your phone on it for all weekend. And it's relatively small. It'll fit in your hand. It's trying to think of compared to the size of two. It's probably if you held 4 AA batteries in your hand, like a little bigger than that. It's portable. It's small. I mean, it's not going to go in your pocket per se, but it'll go in a satchel or a bag or hanging off your wrist, I guess, with the lanyard. It's been really great, and it has this really nice screen. They've actually, I thought like the screens on these that they put in with the percentages and that sort of stuff was just eye candy, but it actually is useful because it's telling you which port is putting out how much energy, and then things like, it's charging, how long it's going to take to charge with this much power coming in to get back up to 100%. And those sorts of things can be useful when you I got to go. How long is it going to take to get this thing charged up again? So it's really useful for that. And you can recharge 3 different things, because not only does it have the built-in cables, it's also got a USB-C port and a USB-A port on the side as well. So you can charge 4 things at once, which is nice. So, and the price is, I have to look at the price was.
It's $109.
$109. So, not the least expensive, but again, this is a laptop charger. So it does a whole lot more than your basic, batteries do. Yeah. So very good. Cool. Those are our picks, and that's our show. We do want to, encourage you that if you got any questions for us or any, suggestions for topics, we love getting suggestions of things you'd like us to talk about. You can let us know by commenting on the show at sqpn.com/technology or our Facebook page, facebook.com/StarQuestMedia. You can send an email to technology@sqpn.com. Visit the StarQuest Discord community at sqpn.com/Discord. You can find links from our discussion and our picks of the week on our show notes at starquest.fm/TEC289. Be sure to follow us in Apple Podcasts, Spotify, TuneIn. We're in your favorite podcast app, or at our YouTube channel, youtube.com/StarQuestMedia. We should make sure to hit the bell to get notifications. And until next time, Jack Baruzzini, thank you for joining me and sharing the secrets of technology.
Thanks, Tom.
And Thomas Sanjurjo, thank you as well.
It's been great.
And once again, I'm Dom Bettinelli. Thank you for listening to the Secrets of Technology on StarQuest. Here's another show on the StarQuest network you're sure to enjoy, The Secrets of Stargate. Find it wherever fine podcasts are found or at sqpn.com/Stargate.